We've been exploring the inner solar system, so now let's go to the outer solar system. So after Mars, the next planet out from the Sun is Jupiter. Now, these outer planets here, these are all gas giants. We call them that because they're actually quite big, and they're all actually very gassy. So these are mainly gas planets. So we're not even sure if there's even a rocky interior, but there's certainly lots of really thick gases. So because of that, just because they're all very gas planets, we don't think that there's likely to be life there. I mean, Jupiter is huge. It's a gas planet. It has these gigantic storms, this big red dot here, this giant storm that it spins and it rotates around. And actually, Jupiter is by far the largest planet in our whole solar system. So it's really, really huge and has lots of moons. Now, this picture is really neat because see this little dot right here? That's actually one of its moons called Europa. And we're going to learn more about Europa, and we're going to see some beautiful picture of that one right there. But this is one of its moons that's sort of in front of it. And some of the interesting missions that have gone near there or taken pictures there are one called Galileo, and there was these original ones from the 70s and 80s called Voyager 1 and Voyager 2. Those are amazing ones that actually traveled in the inner and outer solar system. And some of our farthest objects that humans have ever sent out are actually Voyager 1 and 2. So those are really interesting, I think. There are some other really neat ones too that went out far, like Pioneer, for example, but these are the ones I think are really interesting, at least. That's for Jupiter. So again, Jupiter, large gas planet. We don't think it has life. Saturn, for example, is also another large gas planet. It's neat because it's got these beautiful rings. Look at this real picture here. So you can see it's the shadow of Saturn right here on its own rings. That's because the sun is over here. So this right here is creating a shadow over here. Isn't this a beautiful picture? There are hundreds and thousands of rings of material going around Saturn. That's a beautiful one. You can see there's lots of storms there. There's lots of really, really high winds going across the surface. We don't think Saturn can have life either, and again, because it's a large gas planet. So again, not likely to have life. But this one has lots of moons as well. The next planet out is called Uranus, or Uranus, this is an interesting one because its axis of rotation is tilted. So in other words, all the other planets in our solar system, they all do something. They all sort of rotate around their own axis. If this is the planet, they all sort of spin around like this, but at the same time, they also sort of orbit around the sun. But the way that they spin is sort of related. It's in the same plane as the way that they go around the sun. Well, Uranus is actually really crazy weird because this one is actually tilted, which means what it does is it's tilted on its side. What I mean by that is that over here, if we looked at this, instead of spinning sort of left to right like this, it sort of spins like up and down. It sort of spins like this way, even though it still orbits around the sun, further out like this right here. If this right here was the sun in the middle, that right there was the sun, for example. This in here, its orbit is sort of tilted, so you can see these clouds, for example. Those tell you that it rotates like this, like up and down like this. All the other ones rotate sort of left to right in this particular axis of pictures. So they're not sure why that happened. It's theorized that maybe it got hit by some really large collision and maybe that knocked it on its side. It's possible. We're not quite sure. The next one out after that is called Neptune, and it's again another gas giant. Really, really high winds. And these ones, Uranus and Neptune, have not been very closely monitored. These a very long time ago did Voyager 2 pass by them. So we actually don't have much data on them. Again, these ones have moons as well, but we don't think they're likely to harbor life. Again, that's because they are gas planets. We don't think that there's much place for life to actually live. We certainly don't think there's any liquid water there. We think it's too far out, and it's the conditions are not nice for life. So you might think, so that's it then? No, because there are other ways for life to live outside of the habitable zone. Remember we talked about the habitable zone in past videos. And the way around it is this. Some moons of the large outer planets. So some of these other planets that we looked at, we're going to look at some of the moons of Jupiter as well as some of the moons of Saturn. Those are places where we're very interested in looking for life. So although the big planets themselves may not be able to have life as we know it, maybe their moons can. This is a picture of Europa. this is one of Jupiter's moons. If I go back to Jupiter, that's the one, this little dot right here in front of Jupiter. That little dot right there, that is a huge moon. It's called Europa. Now what's really interesting about it, first of all, this is a real picture. Isn't that beautiful? So this right here is a picture taken. And what's really interesting about it is that it's got icy crust here. It's got an icy surface. You don't see many impact craters, and that's because the ice is sort of, it's being renewed. You see all these cracks in the ice. But what's really interesting is remotely we can actually detect if there's liquid water underneath. And they're quite certain, at least they're fairly certain, that there is liquid water underneath an icy crust, which is awesome. How cool is that? I mean, they're actually thinking that the water underneath is actually liquid because of tidal heating. And now it's actually many kilometers thick, this particular icy crust here. So we think this here is many kilometers thick here. So this is ice. But underneath that, we think that there is a really thick layer of liquid water. Now, because of what we know about extremophiles, see, in the past we thought, oh great, there's liquid water, but there's no way there could be life because the sun can't reach there. You need an energy source, right? If you have liquid water, you still need an energy source. But on Earth, we found extremophiles that live at the bottom of the ocean, and they have no sunlight. And they get their energy in other ways. So we're thinking that maybe it could be possible for life to survive underneath this icy crust here. So what's really cool is that there are actually plans. I've heard about these really interesting plans to actually land a rover on it. And imagine then it could get really hot and melt its way through the ice. And then after that it could sort of drive around underneath the liquid water, and see if some sort of alien sort of licks the camera. So how awesome would that be? So it's really interesting, and it may be possible that it has life. Although no sunlight as an energy source from life has been found on Earth in similar conditions, deep under the oceans, so maybe it could be possible at least. It's certainly interesting. Another of Jupiter's moons is called Ganymede and has a very similar story. So it may have liquid water under an icy crust, but I can tell you the most interesting one I think is Europa, as well as Enceladus, and we're going to talk about that. Ganymede may have liquid water under an icy crust, and again, same story. So maybe there could be life there. We think that the liquid water is liquid because of tidal heating. So that's, because it's sort of being ripped around and moved around so much as it orbits Jupiter, that maybe those pulls and pushes are actually creating friction, and that's heating up the ice into liquid water. There could also be some from the core as well, some heat. So Ganymede is an interesting of Jupiter's moons. Another interesting one is Callisto. And again, same story. Maybe there's liquid water. So these I think they're really pretty neat. But again, we're not 100% sure. So let's move our way on to another moon, this time around Saturn. So Saturn has one of its moons called Enceladus. I've heard some people call it Enceladus. But anyway, this particular moon here, Enceladus, I'm going to call it, it may also have a liquid water under an icy crust. In fact, this one has strong evidence for that. Look at this beautiful picture here taken. And these things are here, they've actually called these tiger stripes, these little cracks in the ice. And what's really cool about it is this is one of the few moons that is geologically active. Now what I mean by that, there's only 4 places as far as we know in our solar system that are geologically active. So places, where they have some sort of volcanoes of some kind or something. So on Earth, for example, we have these hot volcanoes. There's actually another one of Jupiter's moons. So if we go back to Jupiter here, one of Jupiter's moons is actually called Io. So that's got one of its moons called Io. Funny name, huh? And Io, it is geologically active. It has active volcanoes that are spewing out hot rocks and magma, just like volcanoes here do. So that's really interesting. But then comes another example of geologic activity. And this is really cool. This is something called cryovolcanism. So this is when instead of having hot rocks, spew out, we actually have hot water spewing out. So we know that one of Neptune's moons called Triton, we think it has that. But Enceladus here, it definitely has that. So take a look at this picture here that was taken. This is a close-up picture. And you can see these spots where this hot water is spewing out here. So these are sort of like hot water geysers that are coming up many, many, many kilometers up. Isn't that really interesting? So we know then from that that there is liquid water underneath. And again, if liquid water is what you need to have life, maybe there's life underneath there. We don't know, but it is certainly an interesting place to look. Another moon we can talk about is Titan. Now, I really like this particular picture. The reason I like it is that, well, first of all, it's a place that has a temperature that's interesting. I mean, first of all, the temperature is a bit cold, certainly. The temperature is minus 180 degrees Celsius. It is Saturn's largest moon, but it is the only place that has liquids on the surface other than Earth. So the only place other than Earth where there's liquids of some kind laying right on the surface is Titan. And it is a huge moon. What I really like is in this picture right here, this is a picture of Titan, and you can see its atmosphere here is really looking blurry. Look at this little thing behind there. It looks kind of like the Death Star from Star Wars. That's another one of Saturn's moons. It's actually called Tethys. But this probe called Cassini, it took lots of really cool pictures of this. So it took a lot of the other ones as well of Enceladus. But this one is really cool because it has a methane cycle. Now, it doesn't have a water cycle. We don't think there's any liquid water on its surface because it's too cold. But an interesting thing, though, it has a full methane cycle. What I mean by that is that there are methane lakes. There is methane clouds. It rains methane. There's methane snow. So what's really cool is it has a full cycle, just like we do with water. Sort of, they can be liquid water and gas water, and it evaporates, goes into the clouds, it falls down again. They have the same sort of thing, but with methane. I think that's really, really cool. So again, it's the only other place in the solar system where there are stable bodies of liquids on the surface. Now, it's not water, though, so that's a little bit too bad. But its atmosphere is rich in organic compounds, so it has the materials that you need to make life. What I think is really cool is this, that Cassini, this probe, it actually landed on the surface of Titan. And when it landed, it actually saw small pebbles. So let's take a look at this. So this lander, Cassini, in 2005, it actually landed on the surface. It was actually called the Cassini, that was the name of the satellite or the robot that was sort of sent in orbit. But it had a little probe called, now we say Huygens, but it's a Dutch name, so I think they say like Huygens or something. If you're Dutch, you can probably pronounce it better than I could. But this particular probe, it landed, and this is the one picture we have of the surface of Titan taken from the surface. We have other pictures taken from above the surface, but I think this is really cool taken on the surface. When it landed, this is what it looks like. And these pebbles here, those are actually thought to be solid water. So this is ice, which is really, really cool. Now, could there be future life? Well, in the future, when the sun heats up and becomes a red giant, the habitable zone is likely to move, outer. So maybe then a Titan will end up having life because maybe it could have liquid water when it warms up. So could there be life at that point? Well, maybe. I mean, there's an energy source, there's the right materials, there could be liquid water, and there is an atmosphere. Now, what I think is really interesting is its methane cycle. It has these methane rivers and lakes and rain and snow. Now, in these lakes, though, a methane lake would be really interesting because you likely couldn't actually swim in it. So if there was sort of a lake there, let's say this was here as a lake of methane, you would likely, if you're trying to swim in it, you would likely just sink right to the bottom. And that's because it's not very dense. So because that, you'd likely sink right to the bottom. In fact, it has very low gravity on this planet. It's actually 7 times less than our own gravity. So that means that, there'd be much, much larger waves than on Earth, and they'd actually be 3 times slower. So can you imagine then 7 times larger waves? I think it would be really interesting to think about. But of course, they go way slower. So that could be really interesting for like surfers or something, could have a really wild ride. Now, liquid methane is flammable. So you might think, oh God, do you want to light a candle here? Well, probably not. It's very flammable. But the good news is it's not flammable in a sense because there's not really any oxygen. You need oxygen in order to burn methane. So it probably doesn't. But I think it really is interesting here. So this is Titan. This is another picture. This is taken using some special filters to see through the clouds. So you can see these dark spots are actually thought to be lakes of methane on its surface here. So large bodies of water or oceans of liquid methane and ethane. Really, really interesting. So we've just looked at a tour of our own solar system and where we're looking for life. In the inner solar system, we have Mars. That's really interesting because we know it had past water, liquid water. The outer solar system, the actual planets themselves don't seem as interesting, but some of the moons are really interesting, like Enceladus, like Europa and Ganymede and Callisto. So those are really interesting places to go and take a look. So although we haven't found life on these places, we're certainly looking.